Hello everyone, and welcome again to our Microsoft Cloud for Manufacturing webinar series. My name is Dmitry. I am the solution consultant here at OntargIT, and today we will have a talk about the assets, about asset management, about manufacturing, about Internet of Things, about field service, and other things our webinar's agenda says. But actually, we will have a talk about how a business can increase its revenue. Because doing business is creating profits, it's the definition. And Microsoft Cloud for Manufacturing here is a tool or even a way to accelerate your processes, to minimize losses, to have a clear picture every moment, and to bring the leverage to the table. So let us begin. First of all, why do we have this talk now? Because the industry wants it. Specifically after the recent pandemic impact, which disrupted global supply chain. Leading experts in the manufacturing space predict that as organizations build resilience to the risk from future disruptions, they also want to sustain profitability by saving costs. And maximizing the life of the assets, it reduces capital expenditure. More and more manufacturers will start treating assets as their internal customers and seek to reduce downtime by almost a staggering 40%. They are interested in increasing operational efficiency by using cognitive technologies and intelligent robotic process automation. This includes involving artificial intelligence, remote assistance for field service technicians, increasing customer satisfaction level, and establishing remote working patterns for white collars. More than 80% of companies are currently accelerating their automation to stay ahead of competition. And industrial goods, it's in the top 3 here. There are 2 key challenges the industry faces: asset downtime and reactive maintenance. Equipment breakdown halting your production, which will delay customer orders. This could happen if the equipment is not maintained proactively, or critical performance signals were missed or ignored. This results in expediting parts and labor overtimes. 25% of overall cost is maintenance, and approximately 30% of that cost is due to being reactive versus proactive. Other costs that are difficult to quantify but very commonly incurred are costs due to bad yield or faulty products, due to equipment malfunction. Also, implications of late orders resulting in customer cancellations or customer going to competitor. Now, pictures are usually more fun than accounting sheets, so let's have a look at the example. Some breakage happens in the field. Serviceman arrives in 2 hours, and guess what? He doesn't have the spare parts with him. And which is more, when after 2 days he has the parts, he needs assistance in the process without any remote tools for this. There is nothing bad in asking for help, just maybe not after 22 hours of downtime already. And the most frustrating part, it will happen again. Those who haven't ever had such a situation are excused to leave the class now. And those who live in the real world might want to have a look at the next slide. There are 5 different kinds of maintenance defined. Reactive, when repair is prompted by customer request. Scheduled, based on a fixed plan regardless of asset condition. Connected, when condition is continuously monitored using operating parameters. Predictive, when we calculate the remaining useful time and determine asset health. And cognitive, when autonomous actions are taken to ensure maximum asset utilization. One might think that the closer you are to the cognitive processes, the better. Well, he would be wrong. Different cases require different scenarios. The only truth here is there is always area for improvement, and you just need to start somewhere. Let's have a look at some examples. One of the key tenets of smart maintenance is that not all activity can be, neither should be, preventative or predictive. The key is how do we empower the frontline workers across the digital hotspots to minimize the downtime and achieve best-in-class mean-to-time to repair metrics. Both IoT, mobility, and augmented reality technologies play a major role in this journey. For instance, a maintenance request can be initiated by a quality control specialist using Teams and maintenance chatbot, just when she discovers an anomaly while performing her day-to-day tasks. This will not require her to know anything about how to do this or file in paperwork and take into the engineering office, but it will enable the maintenance team to have immediate visibility of a potential issue to triage. When applicable, using a preventative maintenance policy ensures a catastrophic failure never to occur. This requires performing inspections and preventative tasks based on a periodic or equipment counter-driven schedule. Further cost saving can be recognized when assets can be monitored remotely via IoT. That will eliminate the need for sending technicians to check the counters or bringing down equipment at unnecessary intervals. Ultimately, intelligent and adaptive machine learning models can be integrated into the overall system that can predict potential failures based on the telemetry coming from sensors via IoT intelligence. And back to the pictures. Now, when we are a bit more with the industry trends, we can easily see what should have been done differently. First, the failure is predicted, no drama. Second, diagnostics is done remotely. The technician arrives with all the equipment needed. He doesn't just fix the breakage. He takes action to prevent this from happening in the future. And when he does need help, he gets it also remotely with all the VR possibilities. What is the important thing here? Zero downtime? Well, that too, but the fact that not only we resolved the problem before it happened, but also created one more satisfied customer, this one might be crucial. Returning to accounting sheets and summing up this part now. What can we achieve by changing the approach? Maximize longevity, improve overall equipment effectiveness, reduce unpredicted shutdowns, and transform the workforce to be safer, faster trained, and well-equipped professionals. This was about what. Let's talk about how. And number one component is Microsoft Cloud Stack itself. At the bottom, we have Microsoft Azure, the leading cloud computing platform which provides ability to gather data from any device, application, or sensor and process that in a very fast fashion. Then it is Microsoft Power Platform, plain as a low-code or even no-code solution that allows us to build custom applications without involvement of professional developers. And then Microsoft 365 with Microsoft Teams and all the familiar Office applications. Plus, Microsoft Dynamics 365 with out-of-the-box business applications for CRM and ERP. All of these are natively built on Azure, the cloud with unmatched level of security, trust, compliance, and global availability. And all of these products are built with interconnectivity in mind. The most relevant cloud components have been built across multiple industries, including manufacturing, all in collaboration with partners and customers in Microsoft's ecosystem. Industry cloud includes specific components like common data models, open standards, and API. For manufacturing, Microsoft contributes to industry-specific communities like the Open Manufacturing Platform, the OPC Foundation, and the Digital Twins Consortium to build the unified interfaces. Also, AI models, sample apps, workflows, as well as pre-built connectors to equipment and third-party applications common in the industry. Dynamics 365 provides the agility and foundation to transition to the cloud. These solutions are uniquely composable. It can easily bolt on to your existing IT infrastructure to work with your legacy systems to start with. Let's say you start with digitizing your maintenance program. You can then use cognitive technologies to go from preventative to predictive maintenance. You can integrate with field service to ensure geographically dispersed assets are also up and running 24/7. You can leverage mixed reality to improve workforce performance, provide faster training, and improve workforce safety and compliance. As you gain confidence, you can transform the rest of your workloads all the way from planning to delivery and transition to a factory of the future. With seamless native integration, you can make data-driven decisions with confidence in real time from a single source of truth and improve the overall resilience of your supply chain. With the Dynamics 365 Supply Chain Management, you can manage the entire life cycle of your asset, all the way from acquiring the asset to retiring the asset. It seamlessly integrates with financial systems and helps you stay compliant with auditors when it comes to capitalization, depreciation, etc. It further helps you connect with ERP systems to manage inventory of spare parts, plant resources, and production based on maintenance schedules. Let's have a brief look at some examples of how Dynamics 365 Asset Management helps here. First, it helps optimize maintenance plans. Schedule calendar entries based on selected maintenance plans. Create maintenance rounds for various assets on which you need to carry out a similar task at regular intervals. View the maintenance schedule to see a list of all the expected preventative maintenance plans, requests, and rounds to be carried out. Use clean, data-driven maintenance insight with powerful dashboards and artificial intelligence. You can predict when a device needs attention and automate self-healing or maintenance steps before any kind of a problem. View product usage, issues, and repair history to diagnose problems and deliver predictive maintenance. And efficiently manage spare parts stock holding. It also enables users to easily view, update, and manage work orders from a single interface. As mentioned, there is another product in the Microsoft Cloud family, which is called Dynamics 365 for Field Service. Well, the name speaks for itself. The solution helps to manage all the service operations, from managing the workers in the field to keeping the record of work orders, service parts, time consumed, and statuses of the assets. For example, resource scheduling optimization enables customers to automate scheduling and drive more efficient operations. It evaluates routes and automatically schedules work orders to minimize travel time and maximize working hours. The engine also responds to reschedules and cancellations. After automatically scheduling, dispatchers still have the ability to manually override them as needed. Let me ask you a question. Modern machines are smart enough to give any data we want. We have all the schedules and situations predefined. We have all the software to deal with every situation and keep the record. Which part is missing here? If the machine tells us about its problems, and the other machine helps us to deal with it, why do they need a human in the middle to connect? The answer is, they don't. With another member of the cloud family, Microsoft Connected Field Service, the data can be gathered from the machines, insights and suggestions can be prepared, actions can be initiated, and all of the above without human involvement. Yep, I like pictures. Simple example here. Alert is thrown by the machine which initiates self-healing sequence of commands. Technician is dispatched if self-healing was unsuccessful. He can resolve the issue on first visit, as all the diagnostic data are available for him at once. From pictures to photos, look at the temperature sensor, which is constantly sending telemetry. The temperature is increased, and sensor is here to report this. There is no need for a human to keep an eye on the temperature. It's all logged, available, and automatic actions are taken to resolve the situation. To stick more to the system terms, IoT Central gathers the data for us. Connected Field Service transfer them to decision-making part, and field service is utilized to coordinate the resolving process. I've listed a lot of tools, and I want to put the puzzle together now. All the tech stack Microsoft is providing being live. IoT sensors, which give the data. Azure IoT Central to process and structure them. Power Automate to deliver the data to field service for resolving. Field service to assist service technicians. And dual write technology to deliver the resulting data to reporting systems like asset management or finance and operations as a whole. And all of these are parts of the cloud for manufacturing. Referring the pink elephant in the room, no, I did not mix up my slides. When you train for long runs, and you run, for example, for 10 miles, it's the last mile which gives your body the actual training impact, long-term endurance. Only 1 mile is important, but you must run 9 miles before to absorb this last mile. You see where I'm getting it. We talked about what. We've talked about how. It's time to talk about how exactly. The following demo scenario was set up based on the tools already available, and it covers all the end-to-end process I was telling stories about for previous 20 minutes. So let's have a look at the live data. Our first step would be IoT Central, as we need to connect our devices first. And first and main thing here is the extensive list of device templates is already provided by Microsoft. These devices are common in the industry, so it's a pretty high chance you own one of them. And if it is so, you just pick it and the template is ready to usage. But if you own some legacy equipment which doesn't support modern protocols, you might use some edge gateway device, which will pick the data from the legacy system and transfer it here, where it is supported. To create an example, I've actually connected my mobile phone here. Well, just because I can, and to show you that it's pretty easy and available. So you can see now that it's already providing some geographical location, battery level, and some values from its sensors, gyroscope, acceleration sensors, etc. IoT Central is not only a tool to connect devices. You can see that it's also a ready workplace for an operator to monitor them, because all these dashboards can be adjusted, can be customized, and they can be aggregated. So not only one device can be displayed here, we can also see the full picture. But again, factory of the future would have plenty of devices, and there would be no need to just look at them by a human operator. That is why we have rules. Basically, a rule is a trigger which initiates some other action. So look at this rule. It's for this sensor, for the accelerometer of my phone, and it is set as if its value is dropped below than -9, the rule is fired. Okay, we fired the rule, but what's next? Next, we take some action. You can see that there are several of them available. Now I'm using just two. First of all, I'm emailing the person responsible. Well, that's pretty common. And second of all, I'm giving the data further to the Microsoft Field Service via Microsoft Power Automate. So I created a workflow and let me show it to you. Remember, I was talking about how it is low-code or even no-code solution. Well, there is my workflow in front of you. 2 blocks, because all the connectors are already available. And first block just picks the sensor and the device, and the second block tells us what to do with it. So filling IoT alert table is the scene, and yeah, we can fill up many fields, and these are pretty well described here but it's not obligatory. I can fill only the things I need. Okay, the workflow has worked. What happens next? We are switching to the field service environment. Now, those alerts are here, but it's not some alert from somewhere, from some unknown device. It was already connected to a device in the setup, so we know what device, what asset actually triggered the alert. And then we take next action. And when I say we, I mean the system, algorithms, not a human operator. So what happens next? Case is created. The case actually connects this alert to the asset, to the customer, and gathers all the relevant data. Maybe some related documentation, or some related purchase or sales orders, or some additional work orders which were taken to resolve it. All this conveniently stored in the case file. And from the case, well, the actual task for resolving the issue, the work order, is created. It has a service account, it has functional location, which was previously connected with our asset. It even has the work or the price list for this specific customer. And the price list can be for hours, for time, and for materials. This work order has already booked the available resource, meaning technician, which is best suited for the issue by his technical skills, is available at the time needed, and is not too far from the geographical location. So the booking was created using this booking assistant I was talking about pretty early in the presentation. But also it could have been done manually also. So this technician, he receives this work order and proceeds to the crime scene, while the information that work order is created and the technical assistance is already here, may be processed back to the IoT central, to the device. And if device has some sort of display, even displayed on the device. So people there might have never noticed that something has gone wrong, but they will see that technician is already heading their way. Okay, technician can use the same interface to operate, or he can install field service for mobile devices, for example, for his phone, and use it there. Use it for what? Use it to report that he arrived at the location. Use it to report that he consumed some spare parts. Use to log the actual time he needed to resolve the issue. Use to inquire some additional documentation. And the most pleasant part, report this work order finished when he finished it. Okay, the issue was resolved. But while we were busy with it, this dual array technology was busy representing this issue in Dynamics 365, in asset management, and in all the system in a whole. So as you can see, asset management is a heart of the system. Here we have all our customers, all of our assets, all of our work orders. Customer asset counters, asset KPIs, asset bills of materials, all their statuses, all their maintenance schedules are here. And work orders can also be triggered from here if there is such a need. And the asset management being a part of a global D365 finance and operations, we can use this data for our global reporting, our global operations, for invoicing, for purchase and sales orders, and for ledger reporting and accounting reporting also. And again, being a part of the family, we can use Power BI tools, embedded Power BI, for great visualizations to give clear picture to operators. We can develop everything we need using Power BI specialists, but some Power BI workplaces and reports are already here, available out of the box. So just a first glance, and we see that Some equipment requires unplanned work orders more often than other equipment and might be worth looking at more closely. This for work order management, and this for maintenance request management, where we can actually see kinds of equipment, kinds of work being done, technicians, equipment needed, and some statistics gathered for us. It might even be displayed not on the operator's workplace, but at some big display in the factory or in the corridor or even in a lobby to monitor some KPIs. But this very fancy looking not cancels all the standard reports we need to submit at some points in time. And I want to show you that these are also available here and available out of the box. For example, work order report. Looking like this. Okay. This demo demonstrated all the technical stack from the start to the end. But this doesn't mean that you have to implement it this way, that you have to implement it all as a whole, all at once. You just start somewhere and you will already see the added value. And while you use just one component of a puzzle, it's still a puzzle which is meant to be together. And where there is one, there will be two and three, and this factory of the future in no time. Thank you for your attention, and please feel free to ask and address any questions to us. Remember, the future is already here, and it's at your arm's reach. See you there.